All right. Hello, everybody. What's going on, Ashley?
Good. How are you?
I'm good. Welcome to the Blockument, where we do, what do we say we do? We do crypto education through everyday conversations.
That is right.
That's right. So how you feeling today?
I'm feeling great. I'm really excited. I couldn't wait to get back and have another conversation with you.
Yeah, well, I can't wait to keep talking about it. I can't pay you enough to let me just sit here and blabber about crypto all day. This week, we're going to be talking about, we're going to do a blockchain comparison, right?
Yeah.
Our first in a little series of blockchain comparisons. I think we're going to look at Bitcoin, Ethereum, and Hyperledger.
I have no idea what that is.
Yes, I bet you do. You just don't know that you do.
Okay.
Yeah, there's a lot of different blockchains, a lot of different projects, and a lot of different perceptions on what everything really is. Mm-hmm. I always found it was sort of beneficial for people to know what the what the core differences is. There's always a lot of focus on this blockchain is fast or this one has cheap fees. Over the past couple years, there's been a lot more talk about the proof of work versus proof of stake, which are some core differences and chains, but it goes a little deeper than that. Consensus mechanisms are pretty important, which is your proof of work, proof of stake, delegated proof of stake, proof of authority, proof of time, proof of storage, proof of location. There's just proof of everything, right? There's a lot of those, which is important. We'll cover that a little bit today. Fees, in my opinion, are one of the least important pieces of it. A lot of people will say maybe it's important because of usability and adoption. But I think once you start understanding why there are fees in the first place, mm-hmm. right, it starts to break down. So do you have any insight right now as far as what's the difference between, if I said, besides proof of work and proof of stake, mm-hmm. what would you say the difference between a Bitcoin and an Ethereum are?
Oh boy. Well, Bitcoin, as far as I know, is kind of like gold, where you put your money to hold it to like a storage of value, and Ethereum is for smart contracts, and that's basically as far as all I know.
That's a pretty good base.
Okay.
That is a pretty good base.
Okay.
We'll do like we did before. I'll come back and revisit it at the end of the show. But I think that's a pretty good base, right? Bitcoin was created to be peer-to-peer cash. If you look at my mm-hmm. hat, right? Mm-hmm. Bitcoin. It was meant to be peer-to-peer cash. Now, what that means even can cause a lot of contention. Matter of fact, it was probably one of the biggest points of contention in the entire Bitcoin space, known as the block size wars. Like, what is Bitcoin's real value? What is it supposed to be used for?
You said block size wars?
Yep.
Okay.
We'll do a whole episode around the block size wars. I think no matter what, whether you're into Bitcoin or Ethereum or Avalanche or Solana, whatever you're into, mm-hmm. Understanding certain key points like that, I think, are important metrics because it sort of goes into a lot of things we're going to cover today. But back to your Bitcoin and Ethereum. Bitcoin, yes, a good way to think of it is digital gold, and Ethereum, a good way to think of it is a world computer, right? That's really what it's striving to be, which is your basic operating system. A lot of people know about Windows mm-hmm. versus a Mac. Mm-hmm. Well, Ethereum wants to be that core operating system that everything runs off of, and then people can build other applications on it. It did that, of course, in the model of Bitcoin. It was originally proposed to be built on top of Bitcoin. Several projects, a lot of things that people think are unique to Ethereum and other core blockchains today. Mm-hmm. That was all already sort of tried and tested on Bitcoin.
Interesting.
Things like NFTs. NFTs aren't new. There used to be a thing called colored coins.
Oh.
which was just a way to sort of take a Bitcoin and uniquely identify it. So you can use it for different things like IDs and things like that. It's NFT.
Oh, wow.
Right? Of course, and this is one of the core differences is Bitcoin isn't built to be this advanced computing base infrastructure, right? So there's only so many things you can do on Bitcoin. That's why you don't see the DeFi world and the DAOs and the NFTs and all that stuff on Bitcoin. The programming capacity just isn't there, and it's not there on purpose. And before we go deep into that, where it is there on Ethereum, and one of the reasons why is you have to think about what are some of the key components. Why do you use a blockchain, right? And if you don't even know what a blockchain is, you can go check out our episode 1, which is, what was our episode 1? What are blockchains and why are they useful? So if you don't even know what we're talking about with a blockchain, you can go back to that episode. But for this one, if you go back to Bitcoin, when it was first created and the white paper first came out, and what they were really proposing was we need a way for two individuals to transact directly, right? The problem historically has been, how do you do that without a trusted third party in a digital atmosphere, right? We've had, you've had other things. You have things like PayPal, right? We've had things like BitGold and Hashcash, which were like the predecessors of a Bitcoin, but without without all the components, which is what makes Bitcoin special. How do you let two people transact without having a third-party verifier who can change the rules on you? Because this is sort of the problem with money these days, right?
Yeah.
You have the Federal Reserve or central banks who pump up money when they want it, take out money when they don't want it, drive us into inflationary periods, drive us into recessions, all based on the whim of what a few people in an office without any input from the public or transparency just decide is best for us.
And mostly people who are like disconnected from what's going on in the real world.
Oh, yeah. These are the type of people, like, I know they make it fun on like talk shows and stuff when they bring like a billionaire on or something. They ask them like, well, how much does a gallon of milk cost? I don't know, $12?
Yeah.
Right.
We're almost there, but
exactly.
I digress.
Right. But that's what, like, how do you get that out? And then you have a set of rules that everybody just plays by, right? And it's just about trusting the system. You have to have something where you can trust. You don't have to worry about the rules being changed arbitrarily on you. So when you get in, when you're doing things, these are the rules. This is what it's going to continue to be. The other key part of that is permissionlessness, right? A problem with a lot of the financial systems and a lot of the systems we have is you need permission to participate in a lot of these things, right? Again, if we just keep it to a simple topic like money for now, when you're dealing with money, I can take some cash and hand it to you. Who's going to stop me? Right? Nobody. So cash, physical dollars, all right, we're good. But once you go any level higher than that, right? If I want to write you a check, if I want to use a debit card, or if I want to use a credit card, a PayPal, a Cash App, at any point, any of these systems can be like, nah.
Yeah.
It's like, I'm going to pay Ashlee for this new gadget she's going to sell me. And I have the money. I use my debit card. And then, Chase Bank's like, nah. And I call up the bank like, why'd you deny it? It's mine. It's like, we thought it was suspicious. It's like, well, it's not. It was me. It's like, yeah, maybe we'll let you do it. Yeah. Get back to us.
Yeah.
Right? I need permission to spend my own money.
Yeah.
Garbage.
Yeah, crazy.
Right? So you want to have permissionlessness. You want to have, you want to eliminate the need for trust in the system. You want to be, that permissionlessness allows you to have censorship resistance, right? That's really important. And then you want to have, of course, security, right? And you need to have transparency, right? Again, if you go back to like the money creation part, one of the biggest problems is we don't really know what they're doing. And this isn't even just a new thing with money, like back pre-70s and 19th century and whatnot, and prior, when even dollars were backed off of hard commodities like gold, right? How do you know that dollar you had was backed by gold? They told you, like, if you come turn this dollar in, I'll give you gold, but how do you know the gold's there?
Yeah, I guess trust.
Exactly. It's no different than people who buy gold now. You know, I was never a gold bug. I'm a rare Bitcoiner in that regard. A lot of Bitcoiners are former gold bugs.
Yeah.
I was really sort of anti-gold. I didn't see the point because it could still be taken from you. You couldn't verify it was there. And most people I knew who were into gold, most of the gold they had, they might have a couple little bars, small, half ounce, kilograms, whatever. They had certificates.
Oh.
It's like, all right, well, you got gold to sort of fight against if something happens, and if something happens, how are you going to get the gold? I got the certificate. Yeah, okay, now go get the gold.
Just like a dollar, basically. Like, it's just a piece of paper with a value on it.
Just a piece of paper, except, and this was my argument against gold, at least paper dollars, the fiat system that's not backed on anything, at least the dollar is the commodity. Mm-hmm. Back when it was backed on gold, how are you going to get the gold? At least now, as long as you got that dollar, that is the base value.
Yeah.
So that you have all these systems, right? Mm-hmm. And this is complicated enough, and we're just really talking about money. Yeah. Right? Yeah. So now you add on something else like, all right, well, this is all cool. I want to be able to do that, but I also want to be able to do DeFi, right? I want to be able to act like Wall Street with the New York Stock Exchange. I want to be able to do those kinds of transactions in a decentralized way. I want to be able to do that without having to
DeFi, decentralized finance.
Decentralized finance, yep. In contrast to centralized finance.
Which would be like what, Wall Street? Or?
The things you find on Wall Street, it would be any of your brokerage firms, TD Ameritrade.
Like a hedge fund or not really?
You could do hedge fund type things. Okay. You could do a lot of things, right? Finance is like, you got money. Yeah. Then you have finance, which is how do you play with money? Yeah. How do you do things with money? That's where a lot of the wealth creation pieces come into play. Mm-hmm. But it's also where a lot of the garbage comes into play, why we end up with the 2008 recession. Right? That's all that for those finance games, playing with your base layer money. Greed can come in. Well, I mean, with everything, though, there's ups and downs, right? It's great for wealth creation, but it's also really easy to screw people over. Yeah. So one of the ways you screw people over, though, is because they're based off these centralized systems. Mm-hmm. So like in the last little bull run we had, and Robinhood was really, really popular for most people to be onboarded into any kind of crypto space. Yeah. But so that would be centralized finance, where you want to place an order, you place it. Mm-hmm. What Robinhood basically does is sort of auctions off all of your bids to like the best buyer, and they extract a lot of value there. Yeah. That's why it was free for you to use if you ever used Robinhood.
Yeah, that was actually something really crazy that I learned in this like Bitcoin crypto space, is that because I was like, oh, cool, like I'm doing crypto, so I'm like decentralized now. But I was using like Coinbase, which I still am, but like, or like those other like Uphold or those other like centralized exchanges. And I'm like, didn't, know that I was still basically operating essentially like in a bank, but it's just like a crypto bank.
Yeah, it's no different than the gold scenario we said earlier, right? Yeah. It's like you go to Robinhood, you bought some Ethereum, but do you really own it? Yeah. Or do you just have a paper certificate? Yeah. Get it.
I was like blown away when I learned that. I'm like, what?
Yeah, many people are, right? So how do you replace a Coinbase or a Robinhood in a decentralized way? Well, Bitcoin showed you a model of how you can do it with base money. So you take something like Ethereum, they're like, well, let's do those same things, but with DeFi. But now you're adding extra layers of complexity and things into it, right? Right. So there's a couple things you have to think about. And so when we talk about what's the difference between like in a Bitcoin and Ethereum, and we'll get into what Hyperledger Fabric is. Sure. So there's let's see, what's the easiest way to explain this here? Mm-hmm. So you have things like the double spend problem, right? The reason you always needed that trusted third party is when you're dealing with digital money, right? If I have a physical dollar, once I hand it to you, I can't sort of take that same physical dollar and hand it to somebody else. right? Once that dollar is gone, that dollar is gone,
Yeah.
right?
Right.
You can do that in the physical realm. What do you do with digital, right? If I give you $1, how do you know I didn't basically copy paste it and give it to somebody else or
Right.
spend it twice,
Right.
right?
Right.
So how historically you would have to deal with that, and how like all Bitcoin's predecessors dealt with that basically was they set up this trusted third party. So every time I went to send you money, they would just sort of verify like your bank does and say, all right, he really does have the money. And then you would trust me, right? Or you would trust the central authority that, all right, they say he's got it. Okay. And then they would do the account balancing real quick so I can't spend that same one twice.
Okay.
Right?
Yeah.
But now we're trusting that that third party isn't going to flake the books, or I don't bribe them to bribe you.
Right.
Right? So that's called the double spend problem. Mm-hmm. This is sort of the genius of what Bitcoin was. It solved the double spend problem, not by creating anything new, but taking a bunch of existing technologies and putting them together, which is introducing proof of work. So you can verify that any Bitcoins that were created, somebody actually had to put in real value to do it, because you have to spend energy, right?
Yeah.
Bitcoin is really just energy,
Okay.
right? Now, because everybody knows proof of work, right? You got to pull in the one of the complaints against proof of work system is all the energy usage.
Yeah.
I don't think that's a problem. You have to use energy. That's how civilization's advance, right?
Yeah.
Where you get the energy from, maybe, but using energy, we have to use energy.
Yeah.
And so every time you see a Bitcoin, you know somebody spent real energy. Yeah. So it's harder for them to fake. Yeah. And if they are going to try to cheat it, it has an actual cost associated with it. Yeah. Right? I can't fake energy spendage. I have to spend energy in order to produce a Bitcoin.
Yeah. Energy meaning like electricity, or like some places are doing like volcanoes, like in El Salvador, right? Or something like
They're
that.
talking about doing that, yeah. But yeah, it's just basically electricity, no matter where you get it from. Some places get it from fossil fuels, some get it from renewables like solar, wind, hydro energy. Yeah, El Salvador was talking about hooking things up. The volcano gives off heat. Flare usage, if you ever live near any like oil refineries and they shoot all that extra
like
fire
landfill.
Off. Well, think of like the fire stacks, right?
Yeah.
That's just wasted energy going into the atmosphere.
Yeah.
You could hook up like a Bitcoin miner to that, and you repurpose that energy instead of just wasting it. Yeah. So Bitcoin doesn't care. Any proof of work system doesn't really care where it gets its energy from. It just needs energy. Mm-hmm. And now you and me can trust that because we know that system has energy sort of put into it, right? So that plus being a distributed system, doing a decentralized mining and node system, that allows what it really isn't that we trust the network, right? Something like Bitcoin is built to be like, I don't trust anybody. Okay. Right? If you're a game theory buff, it's called competitive game theory, where basically there's 10 of us who all want to use a system. I don't trust any of you. The example I always say is like a poker game or something. You're keeping score on a poker game. Yeah. You could have one person keep score, or you could have every single person keep their own little score sheet. Yeah. And at the end of every game, we all look at each other's sheet. Yeah. And then we can see, I don't trust what you put down, but we do compare what we put down, and we can easily identify who's trying to cheat. Because if we're all honest actors, we all should have the exact same score sheet. Right? Well, that's how a competitive game theory decentralized system works. Right? Everybody, we run our own node. That's why owning your own keys, custodying your own keys, that's why that's so important. Not your keys, not your Bitcoin, because when it's in Coinbase, you're trusting their score sheet. Yeah. Maybe they're telling the truth, but you don't know. Right. Because they kept the score sheet. When you have your own keys, as you run your own node, you keep your own score sheet, and then you can compare it with the network. Yeah. And you can tell who's cheating, who's not cheating, make sure you're up to date. So
essentially, like, we are the network.
You are the network.
Each person who is using it becomes the network, right?
Yep. You're your own trusted third party.
Right, and you would hopefully trust yourself.
Yeah. Yep. And if you don't, that's why we can talk to each other, and you can look and you can see, well, mine says this. Everybody else's says something different. Maybe mine's wrong, and you can update, right? Yeah. So, yeah, that eliminates the trusted third party. Another aspect I forgot to mention that's important with any of these systems, to be really useful, in my opinion, is it has to be open source. And that means anybody can see all the code. If you have a program like Microsoft Office, right, that's not an open source program. You might be able to go in, if you know a couple like tools, you can go in and look at some of the code. Yeah. But a lot of it's sort of black boxed off, right? You just can't see how they do it. You'd have to be like a highly skilled engineer to sort of backwards engineer how they make certain things work. Okay. Versus you have these free versions of Word. I think Libra or something was one of them, where it's just like this open source code. Anybody can see. There's no black box. Every piece of the code is wide open. You can see it. It's permissionless for you to take. You can take the code. You can change the code. You can rewrite it to add your own features in.
Could you share it?
You can share what you've done. You can do all whatever, right? That's really important for the trustlessness of the network, because now you can either audit it, something like a Bitcoin, something like an Ethereum, where they're open source. You can just look at the code. You can tell whether or not something is shady or not, assuming you know enough about computer programming to do that.
I do not.
But then you can, just like a car, right? I don't know enough about cars to really tell if it's screwed or not, but I know mechanics. I know a couple mechanics I do trust. Right. And so I can go to them and be like, does this really look good? Yeah. So if you can't verify it yourself, at least you get to choose. You're not being dictated. No, only these select few people can tell you whether this is good or bad. Yeah. Right? And you can always learn how to do it yourself, right? Yes.
You have the discipline for it.
Right. So you have these. Go ahead.
And so you're right now describing proof of work or Bitcoin, like.
Yeah, generally proof of work systems. It applies to most open blockchain systems. Theoretically, some proof of stakes, but we'll get into what the difference is. But yeah, primarily Bitcoin. This is what Bitcoin, how it operates, why it was important, and why it's still sort of the fundamental. It's the sort of ultimate when it comes to history, right?
Okay. And everything you said, does that fall into proof of work also?
Yes, everything I'm saying right now falls into proof of work. Okay. So then you have something like Ethereum that comes along, right? Okay. And like we want to do more. Because we want to not just money. Yeah. Like we love what you're doing with money. Yeah. But imagine if we could do other things. Yeah. The problem was that required fundamental changes. A lot of times it's called the trilemma, right? You can have security, you can have censorship resistance, which is like the decentralization, and you have to have scalability. How many people can actually use the system? So again, a system like Bitcoin, using this proof of work model, it takes security to the utmost extreme. Yeah. And I would say any honest system takes security to the utmost extreme. That's like almost a no compromise. Yeah. But you'll see where the places take compromises in a minute. Then for Bitcoin, the next thing is censorship resistance. And to really have that censorship resistance, you need to have an open, like I said, open source system that has to be, decentralized, permissionless, has to have these key characteristics. So you got to have censorship resistance in a Bitcoin point of view. Okay. You have to have security in a Bitcoin point of view. Mm-hmm. But the thing with a trilemma is you can have two, but you can never have all three. You can pick any two, right? But the third one goes away. So Bitcoin chooses security and censorship resistance. Okay. It suffers on scalability. 7 transactions per second.
Okay, I was going to ask one.
Right? Yeah. It takes 10 minutes for the block time, right? Yeah. If I send you, on average, you're looking at 10 minutes. That's not just some random number. It's like, this old, slow system. That's for a reason. You have this huge permissionless network. Anybody can come in. right? If anybody can come in, I have to give enough time between blocks for everybody to agree on the true state of the chain. You can't do that in a half a second.
Okay.
You can't have a global network of permissionless systems of nodes that could be millions of nodes at some point, right? It's thousands of nodes right now.
Yeah.
Could be millions of nodes one day.
Yeah.
You have to have enough time for them to come to consensus. Or you have to get even more clever, which means less secure with your code in order to find tricky ways to bring people to consensus faster.
Okay.
So those are, but Bitcoin won't compromise on security.
Yeah.
Bitcoin won't compromise on censorship resistance. So it has to compromise on scalability, right? To make something like Ethereum work, well, you have to really consider scalability because you're not just talking about doing money now.
Right.
You're talking about trying to be money. You're trying to talk about being finance, art settlement with NFTs, the DeFi world, decentralized organizations. You're trying to do all the Web3, identity verifications. You're trying to do all these other things.
Yeah.
That's a lot of things happening. You got to be scalable.
Yeah.
Well, where are you going to give up? You got to give something up. That's the true trilemma.
Yeah. Yeah.
You can give up security. You can give up censorship resistance if you want scalability, right?
Do you think there's ever a situation where you could have all three? Like, would it have to be something where it's like quantum computing, like in the future?
I'm not smart enough of a engineer. I'm not an engineer at all.
Okay.
So
If you want to call in and let us know.
right. The yes, I think most things
Like anything possible
eventually
kind of
could be
thing.
possible, but nobody has thought of it yet, right? So it's not possible now.
Okay.
And one day, if it is possible, it changes a lot of things everywhere.
Yeah.
But right now, it's not possible. And I would say some of the smartest minds in computer science are working on these types of
Trying
problems.
to make it happen.
Right.
Yeah.
So it's not like, well, just the right person hasn't. It's like the smart ones haven't really got to it yet. This is some niche thing.
Yeah.
No, I think some of the smartest minds, not just in blockchain, in computer science, period, are thinking about these kind of problems because it would solve so many things.
Yeah.
But so one day maybe, but it's not happening now. And so, like, where does Ethereum start to sacrifice for Bitcoin? So we already know Bitcoin's sacrificing scalability.
Right.
Because of that, it's slower than what other blockchain systems would be.
Yeah. So where?
But if you're
where does Ethereum like take the hit?
well, Ethereum would take the hit. I would say in security and censorship resistance, especially since they moved to a proof of stake, and that's going to be a very debatable, right, concept. There's going to be people like, no, proof of stake's way more. Yeah. But definitely on the security aspect, if only for the reason, if you've ever done any kind of computer programming ever, right, the most efficient code has no code. That's bug-free. If I have, you imagine a hacker writing all the lines. If there's no lines, there's no bugs.
Yeah. Okay.
If there's one line, there might be a bug in that line. It's all logic, right?
Yeah.
As soon as I do two lines, I haven't doubled my chance to be a bug. I've like exponentially increased the chance to be a bug.
Okay.
So for Ethereum to work, even when it was on a proof of work model, before the merge happened, before it became proof of stake, Ethereum was proof of work when it started. It still was sacrificing on security because to make those more complex, like the way NFTs are set up now, DeFi, all these things, to make those work, you have to have more complex code. You're adding code. And now, to my understanding, the scope of Ethereum is so large, there is no single engineer or small group of engineers who sort of have this high-level view of what everything that's going on.
Yeah.
Ethereum is so huge on a code-based side. I'm not talking about like file size, just complex.
Okay.
You'd have to be almost a specialist. You have to be like an NFT specialist in that programming and Solidity and all that to really understand that code.
Yeah.
But there's stuff happening on the DeFi side you don't really get.
Okay.
And vice versa, right? And now you don't have anybody who has this high level view. And some might say maybe Vitalik has it, maybe, right? But that's a problem on security because that means you only have one person who has a high level view. It's such a small group of people who would ever understand it.
So then you would have to trust him, basically. That's where the trust shifts to.
Right.
In that scenario.
Exactly. Okay. Trust me, this won't conflict with this.
Yeah.
Right? And you can see that through improvement plans. So all blockchains have some kind of XIP, right? So Bitcoin has BIP, Bitcoin Improvement Plan, or Improvement Proposal. Ethereum has EIPs, Ethereum Improvement Proposal. So like EIP 5334 or BIP 327 or whatever.
I did not know that.
These are just proposals. Somebody's like, hey, you know what would be really cool if we try this? And then it has to go through this whole, Well, it's if you have this decentralized system, you have to have a way to still propose updates. It's not centralized. There is no CEO who says, hey, we're going to do this. You're this team and this team. There's no Elon Musk with Twitter these days. Like, we don't need you. You're gone, right? Yeah. It's like if you want to see an upgrade, somebody has to propose it, and then you got to convince an overwhelming majority of the participants in the entire system that's a good idea so they can include it, so it can be included in the next update.
And that is proof of work or all?
Oh, that's all chains. Okay. Any decentralized system.
And I don't know if this is a tangent, but like, how would somebody vote on that? Or is that like another topic for another time?
Yeah, in depth, we'll go into it another time, but that goes sort of down to your social consensus, right? Their governance. Bitcoin does have governance. Some people don't think it does. It does. It's just a social governance theory, right? You have developers, you have miners and businesses, and you have users, right? Yep. So a developer, well, they're the ones who got to write the code, so they're going to write it. They can say like, well, here's the new Bitcoin package, download it. Yeah. But if the miners and the users don't like it, they're just not going to download it because it's permissionless. I don't have to run your code. Okay. Right? I can just keep running with whatever, or I can go find developers who will maintain it without those changes that the majority don't like. A little
like an iPhone update, like you're supposed to be able to choose whether you want to update or not, kind of, right? Or
no, like iPhone would be the opposite. Oh, like you have to update. You can choose not to update, but your phone's gonna stop working. Okay. After a while. Yeah. Right. A thing with an open system is it should be backwards compatible. So yeah, we don't want to do it. So if the developers propose something and nobody else likes it, we're not going to run it. If the miners want something, this is what the block size wars was about. They wanted bigger blocks to improve scalability for Bitcoin. Bitcoin at the time could only handle a 1 mega size block, which is like 1/3 of an MP3. Okay. Right? Okay. So it could hold one Bitcoin block is like 1/3 of a standard MP. It's even less really than 1/3 of a standard MP3.
So like 1/3 of a song.
Yeah. Okay. Think of it like that, right? Okay. They wanted to double it, right? Let's make it 2 blocks.
Okay, I can see.
Right. Right. But what I say, Bitcoin doesn't negotiate on security and censorship resistance. Yeah. That's not so much of a security risk. Okay. But it's a censorship resistant risk because now you double the size. If you double the size of the block, you double the size of the blockchain. Okay. If you double the size of the blockchain, you have these larger storage requirements. That makes it harder for an average user to download the entire block. Where Ethereum, on the other hand, was like, well, I think that's a sacrifice we can make. Storage will do wherever, and I won't make a judgment call on either side. Yeah. But Bitcoin's blockchain right now, if you do a full node, if you do a full backup of the entire blockchain, right now Bitcoin's blockchain is, I could look it up, but it's somewhere in the neighborhood of like 430 gigs. So that would be a standard, if you go buy a standard, my iPhone has a terabyte, which is double the size of the Bitcoin blockchain. Oh. So I can fit the whole Bitcoin blockchain in my phone and still have half the space available for my songs and videos and everything else, right? That's how small, right, 400 gigabytes are for something that size. Ethereum, in contrast, that is somewhere, and again, I could be off slightly on the number, but it's someplace around a terabyte plus. It's a little bit bigger than a terabyte. That means I couldn't even fit it on my phone, right?
Yeah.
So if I need somebody to, if I send you some Ethereum, and not if I'm sending Ethereum, if you want to participate in the network, you have to be able to buy double the storage space.
Because you have to have a node to like operate it? Or?
Yeah, well, remember we talked about earlier, like Coinbase, right? You didn't own your Bitcoin, you didn't own your Ethereum. Coinbase does. When you run your own node, you control it.
Right.
It's all you.
Yeah.
Right? So that's a problem. It's just harder the bigger it gets.
Yeah.
And remember, Ethereum is more than twice the size of Bitcoin. Bitcoin has been around for 14 years now. Ethereum has been around for 2015, 2016.
I don't know.
So yeah, before about 5-6 years, Ethereum's been around. So Bitcoin's been around twice as long as Ethereum.
Okay.
And the storage is half the size.
Yeah. Wow.
Right?
Yeah.
So maybe you think that's a problem. Maybe you don't. But it's definitely a difference.
Yeah.
And if you're like, the smaller it is, the easier it is for anybody to run.
Yeah.
Well, then Ethereum is a problem. And this is why.
So there's more barrier to entry on having a node for Ethereum as opposed to Bitcoin.
Correct. Okay. And this is what the whole merge was about. The merge wasn't the big change. The merge happened, A, so they could go to proof of stake, but B, so they can start introducing more complex code. So again, you're taking a security compromise for scalability reasons. Yeah. But then they want to, they have this thing called, what do they call it? He keeps changing. It used to be just sharding. Now it's like proto-dank sharding or something like that. And regardless of what it sounds like.
I know, I'm like, that's horrible.
At the end of it, if you remember, a blockchain is just a database, right? Okay. It's just like a ledger.
Yep.
So sharding is just, how do I take this and break it up? So instead of having one big thing, I have a bunch of smaller ones.
So it's sharding with a D.
Sharding, yes.
Now with a D.
Yeah, not sharding, right.
Okay.
Sharding.
Okay.
So these are the compromises you make in all of these different spots. And these are some of the key differences. And then how those operate, one day that could affect fees, right? So earlier I was saying, like, a lot of people think fees are one of the big differences. And that's what a lot of them use for marketing. Like, oh, we have fees. There was a big thing with Bitcoin and Ethereum in the 2017 bull run. Bitcoin does not scale well, not on its base layer. So when there's a lot of people trying to do things on Bitcoin, the fees go up. And I do remember a point where to like send you $20, I would have paid like $35, $40 in fees.
Is that kind of like a supply and demand situation? Yes. Okay. Yep.
Because all block space is, every transaction, this is why you pay the fee. You're basically, it's an open market. The way I like to think about it is everybody has gotten on let's say everybody knows how a bus works, right? A public bus. Yeah. You get on, you put your fee in, you have a seat.
Right.
Or you get space in the bus.
Yeah.
How blockchains work most of them work are, imagine if there's a suggested fee of, let's say, 50 cents. But you could pay less, you could pay more. So you get on and pay 50 cents. I get on like, well, I want to guarantee my spot. I'm going to pay 75 cents. And somebody else gets on and like, well, they're going to only pay 25 cents, right? Now the bus gets full. Well, it's still making stops. And the next person gets on gets to see, well, here's a full block. The average cost is 50 cents. The lowest right now is 30 cents and the highest is whatever. And that person can decide like, nah, I really want to guarantee my spot. I'm going to pay $1.50.
Yeah.
And the bus is going to let that person off, and whoever paid the cheapest fee is going to kick them out.
Okay, but that's not how it really works in buses, though, right?
No.
Okay. I was like, oh my God.
But you might have a higher quality bus crowd if it did work like that. But yeah, but imagine if that's how buses worked, crazy. Right? So whoever is willing to pay for the space on the bus gets the seat on the bus. It's an open market. So it's like and then if you get kicked off, then you just have to wait till the next bus, and maybe your fee will there. Or maybe you can be like, no, I really need to be on this bus. So you can be like, well, I'm willing to pay an extra $1 to stay on the bus. Yeah. And then they'll just go to the next lowest bidder and kick them off. Oh, wow. But that's how you have a full block size, right?
I did not know that.
Yeah, that's how blocks work. That's what your fees go towards. And so that's why Bitcoin's fees are so high, supply and demand.
Yeah.
There's only a limited supply of block
Right.
space or bus space, but there was a very high demand of people who wanted to ride. And eventually you'll get on, no matter what, with all of these systems,
Yeah.
eventually you'll get on a bus.
Yeah.
It's just, it might not
Slow you
be that
down.
first bus, right?
Yeah. Okay.
So in Bitcoin, maybe instead of having my transaction go to you in 10 minutes, but if you and me know each other.
Yeah.
So I'm sending you like $5 for a coffee
Yeah.
through Bitcoin, and I don't want to pay a bunch of fees for it.
Right.
So I'm going to be like, I'm only going to pay 4 cents for this.
Yeah. Then
And maybe it doesn't go through for a day.
Yeah.
Right?
Yeah.
But I'm good for it.
Yeah.
So
I know where
you're
you
sure
live,
yes.
so.
Exactly. Versus if we're on Ethereum and I don't know you, but we're doing a transaction like we've turned house deeds into NFTs.
Right.
And I want to do this transaction with you.
Yeah.
I'm not giving up the deed to my house
Yeah.
on some trust verification thing. We want to make sure it goes through. So
Yeah.
when you pay, you're going to pay a much higher fee to make sure that deed goes through quick.
Yeah.
So I can release it to you, and you want to make sure you're in that next block.
Yeah.
Right? So the fee structures are different, but the reason I bring this up is in the 2017 bull run, Bitcoin had that high demand. Ethereum, there wasn't really anything happening on Ethereum except for ICOs. And that's a whole different topic. But there wasn't as much happening. So
That's an initial.
initial coin offering.
Okay.
Yep, it's just, yeah. The fees went up, and a lot of people, including Vitalik itself, like sort of dogged Bitcoin at that point. Because they're like, I think Vitalik said like, well, if a fee is anything higher than 5 cents or 15 cents, something like that, anything higher than that, your blockchain is a failure. It's an unsuccessful model.
Look at him now.
2 years later, because one of the reasons the demand was so high on Bitcoin was because to do any altcoins, if you want to deal with Ethereum or Dogecoin, all the exchanges, Bitcoin was the only trading pair. You had to buy Bitcoin to buy anything else. That changed by the time this 2020 bull run came along.
Yeah.
And there was a bunch you could use Bitcoin, you could use Ethereum, you could use a stable coin. There were so many different trading pairs. So the demand wasn't there for Bitcoin. It didn't overload. So now, I just sent some Bitcoin. I sent like a couple $1,000 and it cost me, I don't know, 20 cents, I think.
Oh, wow.
Right? Versus Ethereum, which had a lot of traffic, and I just want to send you a $4 thing, I could be paying $200 or more in fees.
Yeah.
And that's not.
And they were calling that gas, right?
In
That's the same
Ethereum,
thing?
it's called gas.
Okay.
Yep. You pay your fees using gas. Yeah. Well, that can be like a whole other episode
I
thing.
just kind of want to link it for like people who are watching and also like for myself.
Yep. So you have to be able to fix those fee structures or whatever. So you have other chains that'll do things, and this is where we can start talking about like Hyperledger. So Hyperledger is a project, right?
Okay. I'm so curious.
Spearheaded by like the Linux Foundation, which is sort of the godfather of open source stuff. But you have like, I want to say IBM is really the biggest private company contributor to the Hyperledger system, and they have a system called Fabric. So Hyperledger is like this idea of how to create the blockchain. Fabric is an actual implementation of it. And when you heard after the 2017 bull run, you heard a lot of people talk about, it's about blockchains, not Bitcoin, which is stupid. But blockchains, not Bitcoin, and we need enterprise type blockchains. And why I say you've heard about it is because I know people have heard about things like, well, Walmart is doing blockchain. Well, they're using things like Hyperledger Fabric. That's what they're using. Any kind of private company you hear talk about, they're using blockchain, but they don't throw a name on it. Just like we're using they're using Hyperledger Fabric, or there's a couple other variations from other companies or Hyperledger itself. But generally, they're using something like that. And what the key difference, we've talked about Bitcoin and Ethereum at sort of at length, where some key differences are. The way Hyperledger, the way Fabric, I'll start just calling it Fabric from here on out.
So that's
this
kind of
one
like
implementation.
A nickname for it?
Well, Hyperledger is like the overarching, but there's a lot of different implementations.
Okay.
Fabric is the specific one I'm sort of talking about, but they all sort of work similar.
Okay.
So what are some key differences? The most implementations of Fabric are not permissionless. They're permissioned.
Okay.
All right. An argument against using Bitcoin for any kind of enterprise system is if I'm Ford, right, and I want to deal with my supply chain stuff, there's contracts, there's stuff I don't want. The fact that my competition doesn't know how I'm doing it, right? Mm-hmm. That's an advantage for me.
Okay.
I can't just throw that on a public blockchain where anybody can look at the information. So what this allows them to do is take some of the perceived benefits of a blockchain and do it in a permissioned way. So instead of letting you couldn't be if you were in the Walmart supply chain, you couldn't just be some random person who participates in that blockchain system. Walmart would only allow Walmart stores and Walmart distributors and suppliers. Mm-hmm. They're the only ones who would verify and be those nodes. Mm-hmm. So it's permissioned. They have to give you permission. Mm-hmm. It's not, therefore, it's also not decentralized, right? Mm-hmm. It's decentralized within their network,
okay,
right? But it's not decentralized in the purest form of the word. Yeah. Because if you're not in the Walmart circle somehow, you don't get the benefits of it. There's typically no tokens. There's no coins and no token, because the only reason there's a Bitcoin or an Ethereum token is to help with the security model and to pay for the transaction fees, which incentivize the miners who verify it, right, or the validators now in Ethereum who validate the chain. This incentivizes them to do it. Why else are you going to do it if you're not going to make some money off it? It's the best incentive.
So how is it using the blockchain if there's no tokens, just record keeping?
Yes.
Then, okay. So it's like, okay, so it's a record keeping software or program.
And so
they're just calling it the blockchain, or? Right.
They're using blockchain. And, I've expressed this before. It's not that blockchains aren't important, right? They're the best system we found yet to do a decentralized system, right? Mm-hmm. There are alternatives to blockchains that are still distributed ledgers, but blockchain is the one that's been found to have worked the best thus far. But then the question, like you just asked for this, is why use a blockchain when you could probably just use a permissioned database?
Yeah.
Which are cheaper. They're easier. The technology stack is older and more reliable.
I feel like it's to gaslight us into thinking that it's like decentralized, or maybe to like ride the coattails of the new fad or whatever, if you will, like trend. Welcome
to Marketing 101.
Yeah.
Right? So I haven't seen a situation where permissioned blockchains
like serve a purpose?
Yeah, where just a permission database couldn't do it better, and it's easier to sort of operate.
That's so weird.
But that's how they come in. But again, if you look at the trilemma thing, right, your scalability is through the roof, right? Yeah. A system like Fabric has the highest transactions per second than anything, because you don't need tokens, you don't really need that much consensus mechanism, you don't need all these things. Yeah. So scalability through the roof. Security, well, it's locked down and it's permissioned. Yeah. So with the exception of, the biggest security weaknesses typically in those, if I can get into one of your nodes, I could probably get into all of them. Mm-hmm. This is Target got hacked, had a hack, I want to say about 2 years ago. Mm-hmm. Target itself didn't get hacked. Mm-hmm. One of their suppliers or distributors got hacked, but because their systems were tied together, so Target's security was, I want to say, moderately all right, except for the fact that they gave permission to their distributor. Somebody hacked the distributor system and then pipelined right into Target's system, and boom, I got the honeypot.
And so that you're saying that is what could happen.
That's the big security risk in a fabric system, right? It's very permission. Only a small set of people have permission to act in it, so that's pretty secure. But if I can get into one, I can probably get into all of them.
Yeah.
Right?
Yeah.
But security is pretty robust compared to open blockchain systems. Scalability is really through the roof compared to pretty much any blockchain system. But there's zero censorship resistance. There's zero permissionlessness, right? There's zero real decentralization.
Yeah.
And in my humble opinion, if that's the only one that matters, scalability is cool. You got to have security. I don't want to say like security is not important, but if you're not doing the permissionless, censorship resistant part, don't use it. This is a stupid system for you to use.
Yeah.
That's the only reason to use
this. So we did proof of work. And so what is Hyperledger a proof of work too, or is that?
No, most Hyperledger systems are proof of stake.
Okay.
But these are not proof of work versus proof of stake systems. Everything I said about Ethereum is pretty much true when it was proof of work.
Okay.
So this is not a comparison of proof of work versus proof of stake. These are design decisions. These are the key things. A lot of people think the difference between chains are the consensus mechanism, proof of work, proof of stake, whatever, or the fees.
Yeah.
Those are more side effects. Like Ethereum has moved now to proof of stake. Fees aren't cheaper. They're not cheaper because of proof of stake. They're cheaper because nobody's using it right now because we're in a bear market.
So then would you say that the main differences are which of the trilemma they use?
Yeah, the main difference is where you're going to take the compromise. If you look at Bitcoin as the first chain, as the model for everybody else, right? Bitcoin, security, censorship resistance. Those things, non-negotiables, and if it's going to affect those in any way, we're probably not taking it.
Right.
But we suffer with scalability, which is why they need like a Lightning network or things like that to solve scalability. Ethereum is going to be like, well, we need to use more things, right? We need to do more. Yeah. So we're going to take a smaller hit on security because we're going to make more complex code. And then we're also going to try to fix, right at first it was more about taking the security and the censorship resistance piece. But they still had the scalability problem, right? Now they're working on scalability, so they're going to take a bigger hit on censorship resistance to get security.
And so basically...
to get scalability.
So basically, like, why would you utilize one over the other? It seems like you would have to kind of look at the three trilemma options and which kind of is more valuable to you as what you believe, and then decide from there. Okay, I like security and I like maybe scalability. And so I would want to use, I don't know, something else.
So if you're doing NFTs, right, as a summary, if I'm doing an NFT and it's just a monkey picture NFT, right, and it's just this thing and, there's speculation aspects, but for the most part, it's just a monkey picture. Do I need the same security, censorship resistance that I get with my hardcore store of wealth?
Not really.
No. So maybe I can take a sacrifice for my NFT.
Right.
I don't need Bitcoin type security and censorship resistance for a monkey NFT. So maybe you can use one of the other chains that specialize in that. Yeah. But if I'm putting all my wealth into a system, right, I don't want to do that on something that's sacrificed a lot of security. Right. Definitely. Yeah. And I definitely want something that's going to be censorship resistant because I never want to be cut off from my wealth.
Right, exactly.
So you have to make those kind of compromises, and that's really what works, what doesn't work.
Got it.
Right?
Got it.
So you just sort of re-summarized. I think you sort of do have it.
Yeah.
These are the key differences. I picked these three for the first episode because to me, in the scope of all things, all crypto systems, blockchain systems, these three, Bitcoin, Ethereum, and something like Fabric, encompass what the total option set is, right?
Okay.
Everything else out there, your Avalanches, your Solanas, your Layer 2s, your Cosmos, your EOS, your whatever, they fall somewhere on the scale between these three pivot points.
Okay.
Right? And so we can do other episodes where we sort of break down other blockchains and things.
Yeah, I'd like that.
But really understanding these three, that's where you can put everything else on scale and where they really differ.
Got it.
All right. So that's everything for today. I hope you found it sort of beneficial.
It did. I learned a lot.
Sweet.
Had a bunch of like wow moments.
All right. If you enjoyed it, please like on whatever system and platform you're listening to it. You know, YouTube, like and subscribe, and Spotify, like and do whatever you do on Spotify, and Apple, rate us or do whatever.
He is not on any of the socials.
Yeah, I don't really do social, but you can find me on Twitter. So if you want to reach out, if you have questions or suggestions for future shows that you want to know, drop us a line. We have a Twitter account. I have a bunch of accounts, but on Twitter, if you go on Twitter, the Blockument, at the Blockument, and just sort of post your question and just hashtag the Blockument, so we can take considerations or maybe answer your questions on the next show.
And our website, theblockument.com, has a link to all of our socials.
Yep, theblockument.com.
So that's the easiest way to get to everything from there.
Absolutely. And join us next week where we do DYOR. Do your own research. What does it mean and where to begin? So until then, we'll check you out and keep on learning.
Yeah, bye guys.
All right, peace.